Alright, in this tutorial we're going to talk about a few theorems from section 3.3 which talk about parallel and perpendicular lines. So our very first theorem is called Theorem 3.9. It doesn't have any other particular name, but it states something very basic. Let's say we have these three lines, A, B, and C. Now they're not drawn perfectly because I drew these freehand, but we are going to assume that line A is going to be parallel to line C. Okay, and down here in my statement I'm going to go ahead and write that in my first blank because you'll see by the transitive property that that's all this theorem really is. So if A is parallel to C. Alright, now the next part that I want you to look at is, alright, so what if then line C is parallel to line B? Okay. So I'm going to go ahead and state that in the next blank. So C is parallel to B. Now I want you to look at this because we now know the transitive property, and it states that if we have this situation where they have one piece in common, then I can skip by just saying that line A is parallel to line B. So all this says is if line A is parallel to line C, and C is parallel to B, then they're all parallel to each other. So the very last thing that I'm going to make here is my final transitive property statement, which says A is parallel to B. So that's all that theorem states. Let's take a look at the next one. Okay, so our next theorem is Theorem 3.10, and it talks about two parallel lines and a transversal, which all happen to be right angles. They're all perpendicular. So the first thing that I want to show you is, let's first say that line M is perpendicular to line T. I'm going to go ahead and write that in the bottom here. So if M is perpendicular to T, and if you are not familiar with the symbols or the notation for perpendicular and parallel, look up here at the title. Parallel are two vertical lines together, and perpendicular is an upside down capital T. I do expect you to know those and to use them. So the first part of this is, if I have a line M and it is perpendicular to line T, and line N happens to be perpendicular to line T as well, so and N is perpendicular to T, then guess what we can say about lines M and N? Take a guess. If you said they are parallel, you are correct. So if you have two lines that are perpendicular to the same transversal, then they are both parallel to each other. That is all that theorem states. All right, we have one more, I believe. Let's take a look at that. Okay, so for this theorem, this is Theorem 3.11 or 3.11, and in this particular case, we are already going to start with two parallel lines. So I'm already going to know that line M is parallel to line L. So I'm going to go ahead and state that in my first blank at the bottom. If L is parallel to M, all right, and I'm going to say that my T, my line T, is going to be perpendicular to one of these lines. Let's say it's perpendicular to line L. All right, let's go ahead and state that in our next blank here, and T is perpendicular to line L. Then guess what we can say about line M and line T. Take a guess. If you say that they are perpendicular, you would be correct. So if I already start with two parallel lines, and line T happens to be perpendicular to one of them, then line T is perpendicular to the other line as well. And that concludes this tutorial.